we're going to be looking at characteristics of polynomials in terms of the graph. Now, with a polynomial, we know that this could be in the form of 3x plus 2. It could be in the form of 3x cubed plus 4x. So there's lots of different variations of polynomials. So with this, we're just going to kind of look at this in a general sense. So regardless of what you have, whatever type of function you have, if you are looking for the solution, what that means is you are looking for the roots. So roots / zeros are the solution when f of x, whatever that function or polynomial may be, equals 0. Okay, and our roots can be found wherever it crosses the x-axis. So remember, a root and a 0 are the same thing. There are different ways that you could estimate how to find them. You could use a table, or you could use a graph. It really doesn't matter. It's up to you. I'm going to show you how to work with a table, and then I'll show you the graphing side of it. Did not want that in blue. All right, so let's say that I'm working with, my polynomial happens to be 3x cubed minus 2x plus 6. And I want that to equal 0, so I want to find my solutions. I need to estimate using a table where my zeros are located. This is where you pick some values for x, plug them in order to get an understanding of where the 0 may fall in the y category. So I want to pick some negative values. It's easier if you start with a negative and then work your way there. I'm just going to go with these values so far. You could enter this into your calculator, which is actually what I'm going to show you now, because it's going to be a lot faster than me plugging all of that information in. So on a graphing calculator, this is our home screen. If I go to List and Spreadsheets, you can just call this X. So let's go with -10, and you could plug in multiple values. Oops. Obviously, it's a lot easier for me to type these in when I'm using a keyboard. So what you can do up here is you could plug in that list. All right, so what you're going to do is you're going to title this. We'll title it Y. That's what we've been working with. I already did this just as a double check for me. But what you're going to type in is you're going to type in equals. So that way it knows that the title of the column equals. So we're going to type in our formula. 3 times x to the power of 3 minus 2 times x plus 6. You're going to hit enter, and it's going to come up and ask you, is this a column or a variable? You want this to be all variable references, because that way it's going to pull column A's information. And as you do that, it pulls everything in with that -10 and the -9 and the -8 and what so forth. So with the table, we can see here as we keep going, there is a 0 that lies somewhere between -2 and -1 for the x value, and that's because we went from a -14 to a +5. So if I keep looking at this, my number keeps going up. So I probably only have one 0 point, and that's okay. If you wanted to look at this instead graphically, we're going to add on our graph. Notice it says f of 1 of x, which is fine. We can leave this as a function. You're going to go ahead and type in that function. So now you guys can see that this is our graph of that function. And we can see here that there is one 0 point, or one root, which is great. We found that in the table, and we know that it had to be between -1 and 2, which it is. So we can find that 0 point by going to Menu, Analyze Graph. Notice it says 0. So we need to be left of the 0 point and then right of the 0 point. That way you can see that it's kind of shaded in the region here. And then it gives us our 0 point at -1.44. So this would be our solution to our polynomial function. So like I said, this could change. You could have more than one root. You could have multiple roots. You can do either the table method or the graph method. Personally, I prefer the graph method. I think it's a little bit faster, and I have a visualization of what my graph looks like. Because if I do the table, the downfall is I might not know that there's another 0 point at, say, like -50. So I might not have a very accurate idea of how to pick my table values. Where with the graph, I can see it and I know where it's going to lie. So I wanted to expose you to both methods, but like I said, the graph method at least gives you an idea of where things are. Where the table, you're kind of doing a little bit of a guess and check. You could switch this a little bit. Say, for instance, that we change this up. Instead of having this equal 0, what if we had this equal 10? Okay, so this is where I would use a graph as well instead of the table, because it might not come out to a perfect whole number. But what you can do, graphically anyway, we know that it's supposed to equal 10. So what I'm going to do is I'm going to hit Tab. I'm going to have the second function equal 10, or whatever value it needed to be. Right now I can't see it, my graph's not large enough. But you will have an intersection. You can calculate the intersection of where those two graphs meet. That's going to be your solution. So I'm going to go Menu, Analyze Graph, Intersection. I want to be left of the intersection point and then right of the intersection point. So I can see here that it's going to equal 10 at 1.3. You could potentially say it was down here. 1, 2, 3, 4, 5, 6. You could potentially have multiple options. So if you see here, if we did f of 3 equals 6, we have 1, 2, 3. You would have to do the intersection point for each one of those in order to calculate where your points are located. So with that being said, I personally would go to the graph, and that way you can find all of your solutions. Again, if it doesn't equal 0, that's fine. You just need to plug in to a second function the value it's supposed to equal and find that intersection. Other than that, that's how you find your solutions.